Imagine a celestial object too large to be a planet, yet too small to be a star. Welcome to the world of brown dwarfs. In this vast universe, where we have stars that outshine entire galaxies and planets that could fit thousands of Earths, brown dwarfs hold a unique position. They are the underdogs of the cosmos, the in-betweeners, the celestial objects that defy conventional categorization. Here's a surprising fact to kickstart our cosmic journey. Brown dwarfs are sometimes referred to as failed stars. Why, you ask? Well, they lack the mass to sustain nuclear fusion like stars. They're stuck in a cosmic limbo, not quite making it to stardom, yet too significant to be dismissed as mere planets. But don't be fooled by their status, because brown dwarfs have a lot to offer. So, are you ready to dive into the intriguing world of these cosmic anomalies? Brown dwarfs are the universe's in-betweeners. They are celestial objects that blur the line between planets and stars, existing in a realm that challenges our conventional understanding of these two distinct categories. Imagine a celestial hierarchy. On one end, you have your planets, like our very own Earth or the gas giant Jupiter. On the other end, you have stars, like our Sun, burning bright and hot, sustaining nuclear fusion at their core. But where do brown dwarfs fit into this picture? Well, brown dwarfs are more massive than even the mightiest of planets in our solar system, but still not quite massive enough to become stars. They are the celestial objects that exist in the mass range between the heaviest planets and the lightest stars. Consider Jupiter, the largest planet in our solar system. Now imagine an object that's up to 80 times the mass of Jupiter. That's a brown dwarf for you. However, despite being significantly more massive, brown dwarfs lack the required mass to ignite and sustain hydrogen fusion in their cores like stars do. They are, in essence, failed stars, but don't let the term failed make you underestimate them. Brown dwarfs are fascinating celestial objects that allow us to study the intricate processes that govern the universe. They are the underdogs, the in-betweeners, the ones that didn't quite make it to stardom, and yet they are integral to our understanding of celestial formation and evolution. These celestial objects, caught between planet and star, are a testament to the universe's diversity and complexity. They remind us that the cosmos isn't just about the brightest stars or the biggest planets, but also about the in-betweeners. So, if you've ever felt like an underdog, remember the brown dwarfs. They may not shine as brightly as stars, but they hold their own unique place in the universe, offering insights that no star or planet can provide. In the grand scheme of the cosmos, brown dwarfs are the ultimate underdogs. Despite their name, brown dwarfs aren't actually brown. Perhaps one of the most intriguing aspects of these cosmic objects is the color they project. The term brown dwarf is a bit of a misnomer, a colorful one at that, and here's why. You see, brown dwarfs got their name not because of their actual color, but due to a lack of a better term. When they were first theorized in the early 60s, astronomers weren't exactly sure what to call these peculiar objects that were neither planets nor stars. The term brown was simply chosen to represent something different from the usual red, white, and blue stars we are accustomed to. Yet, if you were to look at a brown dwarf with an ultra-powerful telescope, you wouldn't see brown. Instead, you'd be greeted with a sight of magenta or even orange-red. This surprising color palette is due to the absorption of light at certain wavelengths. The cooler temperature of these dwarfs compared to stars like our Sun results in the absorption of blue and ultraviolet light. This leaves behind the longer wavelengths of light, namely red, orange, and a bit of purple, thus giving us a dwarf that is anything but brown. So next time you think of a brown dwarf, envision a radiant magenta or a vibrant orange-red. Even in the cosmos, things aren't always as they seem. Finding a brown dwarf isn't a walk in the park. Imagine trying to spot a single firefly in a field lit up by 1,000 fireworks. That's how challenging it can be to detect these celestial bodies. Their low brightness and cool temperature make them elusive targets, fading into the cosmic background. The fourth surprising fact about brown dwarfs is that, despite their elusive nature, they were not unknown to us. The existence of these celestial misfits had been theorized for over 3 decades before the first one was officially confirmed. Isn't that intriguing? It was in the 1960s when the concept of brown dwarfs first emerged. Astronomers speculated about the existence of objects too massive to be planets but lacking the size to trigger nuclear fusion like stars. They hypothesized that these objects would be dim and hard to detect, just like our elusive brown dwarfs. But it wasn't until the 1990s that technology caught up with theory. Astronomers were finally able to confirm the existence of brown dwarfs. They used advanced telescopes and detection methods that could pick up the faint infrared light these failed stars emit. The first confirmed brown dwarf, named Teda 1, was discovered in the Pleiades star cluster in 1995. This significant discovery was a testament to the perseverance of astronomers and a huge leap forward in our understanding of the cosmos. Fast forward to today, and we found hundreds of these fascinating objects. Each discovery adds a new piece to the cosmic puzzle, helping us understand the intricate processes of star formation and the diverse range of celestial bodies that inhabit our universe. Indeed, the journey of detecting brown dwarfs is a testament to human curiosity and persistence. It's a reminder that even in the vastness of space, nothing remains hidden forever. It's a journey that proves, in the quest for cosmic knowledge, in space, patience is indeed a virtue. When it comes to longevity, brown dwarfs are the true cosmic champions. In the grand cosmic race against time, these celestial objects take the gold medal hands down. Now, you might be wondering what makes them so special. Well, the answer lies in the very nature of brown dwarfs themselves. You see, these fascinating entities exist in a unique realm of astronomy, straddling the line between stars and planets. They're too hefty to be considered planets, yet too small to sustain the nuclear fusion at their core that characterizes stars. This peculiarity, however, gifts them with an incredibly long lifespan. So how long are we talking about? The answer is staggering. Brown dwarfs can continue to emit heat and light for hundreds of billions of years, far longer than a star like our Sun. To put it into perspective, that's potentially over 10 times the current age of the universe itself. Now, let's dive a bit deeper into why this is. Stars, like our Sun, generate light and heat through nuclear fusion, where hydrogen atoms combine to form helium. This process, while powerful, isn't everlasting. Eventually, the star exhausts its hydrogen supply and, depending on its mass, meets its end in a spectacular supernova or slowly fades away as a white dwarf. But brown dwarfs, they dance to a different tune. Lacking the mass to sustain nuclear fusion, they don't burn out in the same way stars do. Instead, they slowly cool over time, releasing their stored heat and light in a steady, enduring glow that lasts for an almost incomprehensible span of time. So, there you have it. The fifth surprising fact about brown dwarfs: their incredible longevity. In a universe characterized by constant change and transformation, brown dwarfs represent a form of cosmic stability. They're not burning out or exploding in dramatic fashion, but instead, they're slowly and steadily shining on, enduring, persisting. In a universe of constant change, brown dwarfs are the epitome of endurance. If you thought Earth's weather was unpredictable, wait till you hear about brown dwarfs. Brown dwarfs, these celestial in-betweeners, are home to some of the most extreme weather conditions in the universe. Imagine a storm, but not just any storm. A storm so intense that it's not just water falling from the sky. Instead, it's molten iron and silicate rocks. Sounds like a scene from a science fiction movie, right? But it's not. This is the reality of weather on brown dwarfs. Their atmospheres reach temperatures so high that chemical compounds like iron and silicates are vaporized. These vaporized compounds then ascend into the upper atmosphere, where they cool down, condense, and form clouds. When the atmospheric pressure increases, these clouds precipitate, causing what we can only liken to rain and snow. But instead of water droplets or ice crystals, it's molten iron and silicate rocks. This brings us to the sixth surprising fact about brown dwarfs. They can have iron rain and silicate snow, an extreme weather condition that makes our earthly hurricanes and blizzards seem like a gentle drizzle in comparison. It's fascinating, isn't it? How these seemingly insignificant objects in the vast expanse of the cosmos can hold such extreme and surprising characteristics. This is just one of the many reasons why brown dwarfs continue to captivate scientists and space enthusiasts alike. It seems weather drama isn't unique to our planet. Despite their elusive nature, brown dwarfs are far from rare. In the vast expanse of our universe, these cosmic in-betweeners are more common than you might think. It's like finding grains of sand on a beach. You can't see them all, but you know they're there, countless and abundant. The estimated number of brown dwarfs in our galaxy is staggering. Picture this. If you were to count every second, it would take you over 792 years to reach 25 billion. That's the potential number of brown dwarfs in our galaxy, the Milky Way, alone. Now, here's the seventh surprising fact. There could be as many as 25 billion brown dwarfs in our Milky Way galaxy alone. Yes, you heard that right, 25 billion. These cosmic objects that are too massive to be planets, yet too small to be stars, are teeming in our galaxy, each with its unique story, each with its mysteries waiting to be unraveled. And while finding them may be like finding a needle in a cosmic haystack, remember that they are an integral part of our universe's grand tapestry. Their abundance provides us with endless opportunities to learn more about the cosmos, about star formation, and about ourselves. Remember, in the universe, rarity is relative. Brown dwarfs may be failed stars, but they play a crucial role in star formation. Now, that's a statement that might raise a few eyebrows. How can something that didn't manage to become a star contribute to the creation of one? It sounds paradoxical, doesn't it? But when you delve into the fascinating world of these astronomical objects, you'll find that they offer invaluable insights into the process of star and planet formation. Think of brown dwarfs as the underdogs of the cosmos. They've missed out on the glory of being a star, but they've got a front row seat to the show. And by studying these spectators, we're able to learn more about the game itself. Brown dwarfs are born from the same material as stars, giant clouds of gas and dust. They start off on the same path, but their journey takes a different turn when they fail to accumulate enough mass to ignite nuclear fusion. But this failure is our gain. Seeing as they're made up of the same stuff, brown dwarfs serve as perfect laboratories to study the early stages of star formation. They provide a snapshot of what a star might look like before it starts shining. And it's not just stars. Brown dwarfs can also help us understand how planets form. Some brown dwarfs have been found to have their own planets, and studying these systems can provide insights into the process of planet formation. They might even help us discover new types of planets that we haven't yet imagined. So, here we are at our eighth surprising fact. Brown dwarfs, despite being failed stars themselves, can help scientists understand more about how stars and planets form. They're like the unsung heroes of the cosmos, quietly contributing to our understanding of the universe. As we continue our journey into the cosmos, let's remember that every celestial object, no matter how insignificant it may seem, has a role to play. Even in failure, there is a contribution to the cosmic drama. Brown dwarfs may not shine like stars, but their composition is quite similar. Now, isn't that intriguing? Despite their size and lack of nuclear fusion, brown dwarfs share a lot in common with their larger, brighter counterparts. Like stars, brown dwarfs are primarily composed of hydrogen and helium, the two most abundant elements in the universe. These elements form a large part of their mass, giving them a composition similar to that of gas giants like Jupiter. However, unlike gas giants, brown dwarfs are hefty enough to fuse deuterium, a heavier isotope of hydrogen, and some can even fuse lithium. This brings us to our ninth surprising fact. Despite their size and dimness, brown dwarfs are not just oversized planets. They are more like miniature, failed stars, with a composition that echoes the stellar giants they could never become. In the universe, it's not just about what you do, but what you're made of. As we gaze into the cosmos, brown dwarfs hold many secrets yet to be discovered. These celestial underdogs are stepping into the limelight as they may hold the key to finding habitable exoplanets. Yes, you heard it right. Studying the faint glow of these failed stars may lead us to worlds beyond our imagination. They offer a unique perspective into the vastness of the universe and the endless possibilities it holds. As we continue to explore, remember, every celestial object has a story to tell. From failed stars to cosmic in-betweeners, brown dwarfs are truly fascinating. These cosmic anomalies, straddling the line between planet and star, have captured our curiosity and expanded our understanding of the universe. They're not quite massive enough to ignite nuclear fusion like stars, yet they're too massive to be considered planets. They're the epitome of cosmic ambiguity. Their detection, often through infrared technology, has revealed a universe teeming with these hidden giants. Their lifespans, stretching beyond the limits of our comprehension, and their role in star formation continue to amaze us. Despite their misleading name, brown dwarfs are surprisingly colorful, their hues revealing their age and temperature. They've even got their own weather systems, with clouds of molten iron and sand swirling in their atmospheres. And let's not forget their abundance in our galaxy, promising a future of exploration and discovery. So the next time you look up at the night sky, remember the brown dwarfs, the silent, enduring underdogs of the cosmos. As we conclude this celestial expedition, we look forward to having you accompany us on further explorations of the universe's captivating secrets. If this trip through the fascinating realm of brown dwarfs taught you something new, then we'd appreciate if you could hit that like button. Even though it's a small action for you, it brings brilliance to our world akin to the stars illuminating the night sky. We're eager to know your opinions, so don't hesitate to leave comment below. What fascinated you the most about brown dwarfs? Are you interested in watching more videos on similar cosmic anomalies? Your input greatly influences our future content. If you haven't already, do consider subscribing and tapping the bell icon, ensuring you never miss our celestial expeditions. And lastly, if you believe your friends or family would relish this journey into the universe as much as you did, feel free to share this video with them. Remember, while the universe is immense, it's always more entertaining when explored together. Until our next adventure, keep your curiosity sparked and your gaze fixed on the stars.